Hello, this video is going to be about flight controllers, and we'll take a closer look at how they get connected up to the various things that they get connected to. So we'll see what all of these pins do on here, well most of them anyway. And you may recall, just to recap, that the flight controller sits kind of in the middle of all the other bits and pieces and organizes them all and brings them together. And we have seen receivers and the kind of communication that they have on their wiring and also ESCs. So we'll be able to figure out how the receiver and the ESC come together at this point. And again, this is not going to be a super detailed look at everything, so we're not going to look at how you set up the configuration software for them or anything like that. Just wanted to get you familiar with how they're laid out and what sort of connections are on there. So as we know, a flight controller is a little computer, and I have three examples here that I'll take a look at during the course of this video. And these are pretty typical things that are in use these days. And they are a 32-bit CPU running at about 72 megahertz for the lower end ones. But things are changing very, very quickly, and the 72 megahertz CPUs are already starting to look a little bit slow. But if we go back in history a little bit more, not that long ago, just a few years ago, if you remember this thing that I had in one of the previous videos, this is an 8-bit CPU, and it's running at 16 megahertz. So it's quite a bit more limited than these other ones, and it has a lot much fewer connections as well. It's only 48 pins total, I think, on that one. But even this is fast enough to bring in the signals from the gyroscope and process everything and output the signal to the ESCs in order to fly a multirotor. And this whole multirotor thing sort of really got started, at least in the open source community, when people realized that these Wiimote things have a gyroscope and an accelerometer in there. So when you're playing games with this, it senses, your rotation and stuff like that. So they pulled out the gyroscope and those bits from in here, and they paired them up with I think this was probably commonly what they used, this Arduino board or something very similar. And they called that the multi-Wii because it was multi-rotor flowing with the Wii hardware, or some of the Wii hardware. So if you hear the name multi-Wii, that's what that's talking about. It's this older generation. You're probably not going to see too much of that in the future because everything is, like I say, it's changing very quickly, and everything's getting a lot cheaper. So let's take a look at some of these flight controller boards. These of course, they have the CPU, and they also have gyroscope sensors on there as well. So it's basically something like this with just the brain, and it's also the gyroscope sensors from inside one of these. Well, not the same. Actually, it might be the same. I don't know. But the point is that they're all on one board, and it's much easier to use than having to make one yourself. And it also has a nice USB connector on here to connect it up to your computer and upload new firmware and change the settings and so on. So the pins on here is what we're kind of interested for this video. There are a lot of pins on there, but don't worry, because as we saw with the receiver, a lot of them are actually just the same thing, all connected to each other. And a good example of that is this set of, we've got 8 rows of 3 going down there. And we can see this label here which says RCCH, and this is short for receiver channels. So this is where you would plug in connections to your receiver, or from your receiver, because the signal's coming in to this side. And this row is labeled G for ground. And all of these pins down here are all connected to each other, as we saw with the receiver. The middle row is V, so that's volts or power, and 5 volts in this case. And again, all of these pins in that row are connected to each other as well. The innermost row is where the pins are not connected to each other. These are the actual signal pins. And this one's labeled 1, so this is receiver channel 1. And to connect that to your receiver, you would use one of these servo cables, and you would plug it in there. So you've got black, so it would be like that. You've got, typically we would color them black, red, white, or black, red, yellow or something, and then the other end would go into your receiver. And if you want 6 channels, then for normal PWM connection you could use 6 of these wires, but since we know about PPM and serial connections, we are not going to use 6 of these wires to do our build. That would be old-fashioned. Let's not do that. Okay, so that is the receiver connection incoming. Now over on this side we have the ESC connections, and this is outgoing information to the ESCs to turn the motors. But again, it's a very similar situation. We have a ground rail and then a positive voltage rail, and then in the innermost rail, well, I shouldn't call this one a rail because they're not really connected to each other, but the innermost row is the signals going out to each individual ESC. And we have 6 of these, so this flight controller board could be used to make a hexacopter. But if we're just making a quadcopter, we're only going to use 4 of them. So if I have an ESC here, typically the ESCs that we use these days, as I mentioned, they don't have a voltage wire in the middle. We're just going to be using ground and signal. So these would go on here like this, and there, except, oh, if you're making a quadcopter, you would not put it there because that's channel 6. I mean, that's motor number 6. We're not going to use motor number 6. So we would start from there, which is, it actually has a label there right down the bottom of the pin. It says 1. So that would be going out to motor number 1 over there. And then the next one would be motor number 2, 3, 4, and so on. So that's where you would connect your ESCs. And we have a couple more connections over here. This one's called beep, and I have soldered a buzzer directly to that. So this pin, the minus is just ground, and then the positive is going to be going up and down from 0 to 5 volts. So whenever it's 5 volts, this buzzer will make a beep, and the flight controller is controlling it to turn it off and on. And just above that we have something called VBAT, and this is the voltage of the battery. Battery meaning the LiPo battery, the main flight battery that's powering everything. So this could be quite a high voltage. It's going to be more than 5 volts. Could be up to 12 to 16 volts or something quite high like that. And you need to make sure that you get this exactly right. You need to double check and triple check this connection before you make it, because this is all running at 5 volts, but if you connect, say, 16 volts into the wrong place, you'll fry some of these components, and you might have to buy a new flight controller, which is not fun. So we can see that the one on the right is labeled plus, so that's where the positive terminal of the battery has to go in, and that means that the one on the outside is going to be the negative terminal of the battery. So this one happens to have things labeled fairly well. Sometimes labels are on the bottom. This doesn't really have much labeling on the bottom, but it is fairly well labeled on the top. I'm just going to mostly ignore those other ones down there for this video series, but we'll have a look at a diagram in a minute and we'll see. One of them I'll just mention. But generally, it's a good idea to find a circuit diagram or a pinout diagram so that you can just double check that you're getting everything right, because sometimes these labelings are a bit weird. And one thing that I was going to mention too is that, see how there's a 6 down there? Can we focus, please? There we go. See how it says 6 in the little corner there? I think that should be an 8, because there are actually 8 receiver channels coming in here. So I think that little 6 is a mistake. So anyway, let's have a look at the diagram, the pinout diagram for this flight controller. So here's the diagram for that flight controller board. This one's called the Flip 32, by the way. It's getting a little bit old these days. I don't think they actually make it anymore, but I still have one. So I'll just quickly point out this stuff here. That's what we just looked at. And then over here we have motor outputs 1 through 6 and so on. And I mentioned all this stuff just now, but there's a couple of other things that I was going to say. There's a thing called boot. So there's a couple of pins here called boot. And if you connect these 2 pins together, when you power up the flight controller, you'll enter a different mode. So normally it would just start up and run the program that it's supposed to run, and it does nothing else, but there is a different mode that you can enter to help you load the new program into the memory. So we might have to look at that again in a future video, perhaps. And then down here we have G, V. Again, we know what these stand for, right? From same as those, ground and 5 volts. Actually, it might be lower than 5 volts. Oh, yes, this is there, 5 volts. And this connection here is labeled serial. And if you remember from the last video, a serial connection can be used for to read in the receiver inputs and give us faster response time and so on. So if you want to use that kind of a connection from your receiver, you can use this set of pins to do it, and we'll look at that in the future as well. Let's have a look at another example, and I'll just hold this up here and let you get a look at that for a second. Now we have less pins on here, but it still has all the same functionality, and mainly what they've changed is that instead of having all of these pins for every single channel, ground and 5 volts, because they're all the same, you don't need to have a pin for every one. So what they've done here is this bunch of pins down the side, it's just the signal pins, so we've got channels 1 through 8 for our receiver inputs. And then there's 2 at the top there, which are the ground and the 5 volts. As I've just flipped this over, we'll see it's labelled there. So we've got ground, 5 volts, and then we've got receiver channels 1 down to 8. And there's actually PPM label on there too. So if you want to use PPM, this is the pin where you're going to have to use, where you're going to have to connect the PPM input coming from the receiver. So that's a helpful label there. Right at the top we have again 6 motor outputs, so we could make a hexacopter with this board as well. And does it say anything about this? What does it say there? Okay, so we've got a minus, so we've got negative, positive, so this is ground, and then 5 volts, and then this label means signal, and this is kind of what we saw on the oscilloscope before. There was like a square pulse going up and down, so that's what that means. The signal is on this row of pins. What else do we have? Okay, so we have a few other connections over here, and we have this VBAT thing again, so we can connect LiPo directly onto there, making sure we get the plus and the minus around the right way. And these are not labelled there, but they are labelled on the back. Okay, and we have a buzzer again. And then we have another ground and some other things that I'm just going to ignore for the time being, but keep in mind there's a buzzer and a ground there. So this is a pretty simple board, and again this is getting a bit old. The processor that's on here is looking a little bit dated, and things are getting quite cheap these days, to the point where this kind of board is, I wouldn't say it's not popular. I think a lot of people are still using them. I'm still using these. So this is what I'm going to put in both of my quadcopters in this build series, one of these boards. But a lot of people are moving on to faster processors that are more capable. They can handle more inputs from things like, well, just GPS is a good example, and lots of connections, and they can handle everything a lot quicker. So this is a little bit more what people are using these days, and it has also on the back, it has an SD card reader. So where should we start with this one? Let's just jump straight to the diagram for this one. It might be a little bit easier than me trying to hold it in front of the camera. So on here, over on the right hand side, we have M1, M2, M3 and so on. So these are the motor outputs going to the ESCs, and we have up to 8 motors for this one, so we could make an octocopter with this flight controller. These ones here do not have a 5 volt and ground rail going all the way down, but we know that these ones up here do have the 5 volts and ground, so we could just connect it onto there somehow and we could make it happen. Notice that we don't actually have a pin for every receiver channel this time. So for this flight controller, you're going to have to use PPM or one of those serial things like iBus. And over on this side, we have a bunch of rows of 3, very similar to that first flight controller that we looked at. So it might be tempting to think that the outside rail is all going to be ground, 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 ground all the way down. And, you know, like we saw with the middle rail was 5 volts all the way down. But that's not the case with this one. So it really is important to get hold of one of these pinout diagrams to make sure that you're going to get everything in the right place. I mean, look at this one, 5 volts, 5 volts, 5 volts. So all these pins here are 5 volts. So it's very different over here on this side. Yeah, so I'm not really going to go into too much detail about this one. I just thought I'd sort of drive the point home that this pinout diagram can be quite important. So you can see there's actually no labels printed on here, or at least not really much. What is this here? These 4 labels are actually for these little pins here, so that's for something else. So there's actually nothing printed on here, so it's not very useful at all without one of those diagrams to let us know what these connections are for. By the way, the SD card on the back is for something called black box, which lets you record some data while you're flying that might help to diagnose problems that you're having, and it can help you with tuning your flight performance to get things running as good as they can. And there's also a bunch of other things on the back here which I'll just quickly mention before we finish up. This set of things here is for an on-screen display. So this board, as well as flying the quadcopter and doing a bunch of other things, is capable of reading in your video from your camera and overlaying some text and some symbols on it so that you can see on screen while you're flying through your FPV goggles various information, like, for example, how high you are, how fast you're going, and if you have a GPS connected, you can see the direction to home and what mode you're in and all that kind of stuff. So this board is pretty capable, and these days it doesn't cost a whole lot more than one of these. So I'm sure that some people are going to be in the comments of this video saying, Chris, why are you using this cheap crappy one? Well, they work alright, and we're just doing a basic build series here, so I have a few of them sitting around too, so I'm going to use these for my builds. One other thing I wanted to cover in this video was the type of software that we use to communicate with these flight controller boards, and this is something that we're going to spend actually quite a bit of time looking at in the future. But for now, I just wanted to give you a quick idea of what it's like and where it comes from and what it looks like, basically. So I have this flight controller board connected to my computer through the USB cable, and the way this works is that you need to use the Chrome web browser, and in the Chrome web store you can get a flight controller configurator app for the Chrome web browser. So the Chrome web browser, you can run that on Windows or Linux or Mac or whatever, and it's quite easy to put new apps into the what do you call this, the apps page, I suppose. So I have a few different things. Whoops, that's not what I wanted to do. So there's a few different types of flight controller firmware that you can get, and they are for various purposes. But the one that we're going to spend most time looking at, well, the only one that we're going to look at in this video series is this one called Betaflight. And this is made primarily for racing and fast acrobatic flying and freestyle flying and stuff like that. And the other one that I use quite often is iNav. And they are both came from the same original source, and they've branched out to be more specific. So the iNav one is all about GPS features and, you know, automatic flying, return to home and position hold and things like that. So we're not going to look at that for now. And then this Clean Flight one over here was actually, this is like the parent of those two. So this is where these two have branched out from. And they're all very, very similar. And you can run them in your web browser like this. So let me just start up the Betaflight one and we'll see what this is all about. So this is what the Betaflight configurator screen looks like, and if I click connect up here, we can connect to the flight controller board, and we can just double check that we're connected by the fact that, oops, can I get this all on screen? Yes. So you can see that when I move this, the little model in there is moving to match my movements, so that just sort of confirms that we're actually connected, I suppose. And there's a bunch of pages on here that we are going to look at in quite a bit of detail in upcoming videos, but for now I just thought I'd give you a quick once over of some things that we have on here. Actually, one thing I might mention, since we were talking about receivers in the last video, is on this configuration page there's an area here. Now you should know, if you watch those other videos, what this is all about. So we have receiver, and then we have PWM, one wire per channel, and then we have some other options. One of them is PPM, we know what that is, and we also have serial based receivers. So this is S-Bus, or if I select that, then we can choose what kind of serial receiver we have. So we had iBus for the one in the last video, so there should be an iBus down there. So this is kind of which company is making the the receiver that you are using. So I would choose iBus for my particular case. So that's just one setting. That's the kind of thing that we can choose in the Betaflight settings, among other things, many other things here to look at. But that will be the subject of a future video. Actually, just before we finish, let's try connecting a receiver and an ESC and a motor to this flight controller, and we'll take a quick look at some other things we can do in the Betaflight configurator. I also had to connect a 5-volt supply to this because on this particular flight controller, the USB, which is 5 volts, does not actually supply power to all these pins that are marked with V, so I have to give that some 5 volts. Anyway, over on Betaflight configurator, we can now see. Let's go to the motors tab, and we can actually test the motors like this. So if I check this box to say I understand that this is dangerous and I should remove my propellers, which I have, no propeller on there. Now I can use the slider to control the motor. And now, hopefully from watching those earlier videos, it should make sense why when the motor is stopped we have a value of 1000, and when the motor goes to full throttle it should be 2000. It's not very good for the motors to do that, spin them empty like that, but just for a little bit it's okay. So that's, now you should know why it says 1000 up to 2000 on this bar here. And on the receivers, if I just go back to that configuration tab, I have my receiver set to output ppm, and I have selected ppm RX input on the flight controller side, and of course on my transmitter I also had to set that up as well for this particular transmitter. So I have ppm. Why is it off? Whoops. Okay. So ppm output is on, and now if I go to this other tab called receiver, now when I move the sticks on my transmitter, we can see each of these channels giving us some values, and again these values are from about 1000 to about 2000. A little bit off here, aren't we? And you can see them sort of jittering around, and that's because this ppm, the way it works as we saw before, is that one side, the sending side, will make that pulse go high for a certain amount of time, and then the receiving side just has to check its clock and see what the time was, and the clocks may not be exactly the same. So for that first row there, you'll see sometimes it's 15:10, sometimes it's 15:09, 15:11, so it's around about there. So we don't always get out exactly what we put in, but it doesn't really matter because it's just sort of a very small movement of the stick is the only difference it's going to make, so it should be okay for most cases. So over here I have throttle and yaw, and the switches, I think, yeah. This is changing a flight mode, you can hear it beeping. And this one is aux 2. So we've got a bunch of channels there, 6 channels. And these ones do nothing, yeah. So I'm just using 6 channels at the moment. But anyway, hopefully that should bring us full circle, and now we understand all of the connections from the receiver through the flight controller and out to the motor, and we understand what kind of signals are going on between these wires, and it should make a bit more sense now as to why we're seeing numbers like 1510 in sections like this. So I think that's all I was going to cover for this video, and like I say, we're going to have to look at this Betaflight thingy in a lot more detail in future videos, but for now that's going to do it. So thanks for watching, and I'll see you in the next one.